Once in a long while, you get stuck in what I like to call L'Hopital's loop. This is when you're doing a L'Hopital trying to find a limit using L'Hopital that you just chase your tail. You come back to the same original question, and therefore L'Hopital is not going to be the method that will solve it for you. You're allowed to just say can't be solved. It might be solved, but maybe you need graphics or advanced techniques from future calculus courses or whatever. Um, I'll compute one out for you. Let's take, it looks kind of innocuous, harmless, but it turns out to be a big mess. What is this? X squared. Yeah, I think that's it. And of course, we have to have a limit. L'Hopital only applies to limits, right? And sorry, and it's x goes to infinity. So the first thing that we have to make sure is, I told you you can use L'Hopital because that's what the video is about. But in a normal circumstance, you'd have to, maybe check and make sure. And as x goes to infinity, we see, of course, the top becomes infinity. And the bottom, let's check this out. Well, x squared is infinity times infinity is infinity, and the square root of infinity is still infinity. So we get infinity over infinity. So it is indeterminate, right? That is the main point of L'Hopital's rule. You have to get an indeterminate in order to apply it. And remember, if you're going to apply it multiple times, you have to get an indeterminate before you can apply it again. So good, it is indeterminate. And that means all we have to do is derivative of top over the derivative of bottom, right? We get to take the derivatives separately. You know what? I'll use shorthand notation because you're in calculus. You can handle it, right? Top prime divided by the bottom prime. All right, let me move all that stuff over. That's the joy of L'Hopital. To get the limit, you just take these straight derivatives. Derivatives usually help simplify things. Like a polynomial always gets 1 degree lower. So if you got polynomials, they're eventually going to taper away. Right? We've confirmed we have an indeterminate form, and therefore we know that we can find this limit by taking the derivative of the top, and that's easy. That's 1. And oh goodness, the derivative of a square root. I'd better go off to the side, right? And of course, we're not going to be able to compute its derivative until we're writing the square root as a 1/2 power, right? The power rule. So here's x squared plus 1, and it's to the 1/2 power. So when I take the derivative, that becomes, right, power rule, so that's 1/2. And here's the thing, x squared plus 1, and I have to lower the power by 1, so I get negative 1/2. And of course, I have to use the chain rule because this is not just a simple x. I applied the power rule, but there's something complicated inside the parentheses, so I have to multiply by the chain term of the derivative of x squared plus 1, which is 2x. Well, let's rewrite that in a simpler form. The 1/2 and the 2 cancel, and so I'm left with x, and oh, this is a square root, but it's got a negative exponent. So now I rewrite the square root on the bottom. right? The square root of x squared plus 1. And now I kind of cry a little bit because that's my original question, right? Well, oh, wait. I've got to take the derivative. This is the derivative of the bottom square, the bottom, right? This is that. Maybe that'll help, right? So this is 1 over x over square root of x squared plus 1. And so the answer here is, right, 1 over a thing is take its reciprocal. So now it's the square root of x squared plus 1 all over x. And now I'm kind of, oh, that didn't help much, right? Because, all right, that's the answer. I have to take the limit as x goes to infinity to make sure it's indeterminate. Yes, I get infinity over infinity. So yes, I can apply L'Hopital's rule. So yes, I need the derivative of the top, but we already determined the derivative of the top is x over the square root of x squared plus 1, right? And the bottom, just the derivative of x, that's 1. And now you go, oh, right, division by 1 is like doing nothing. So I am back to the original. This and this are the same thing. So by going twice, I came back to the original. There's a loop. I'm stuck in an infinite loop, right? Can't get anywhere when you're stuck in an infinite loop, right? You've probably seen a science fiction movie with that theme. You go back in time, but no matter what happens, you can't get out of the loop. It just sends you back, and you got to go back, you go forward, you go back, you go forward. It's an infinite loop. You can't do anything. So there is no answer with L'Hopital. Now, that does not mean there's no answer. It just means there is no answer with L'Hopital. There might be answers other ways. We will not get into that because that's beyond the scope of this course.